So now we are diving into example 5, which, like before in our last example problem, we are going to be graphing the piecewise function, but we have a second component. We will also be stating the domain and range. So get pumped up. Domain and range is the blast. So before we get going on graphing our lovely piecewise function, the first thing we're going to talk about is where each function occurs on the graph. Like in the last problem, there will be certain sections on the graph where each function is allowed and is not allowed to be on. So we have to be careful when we're graphing piecewise functions. Now, the tables I have below we're going to focus on later, so just ignore them from now. So, the numbers that fall on my lovely graph are the numbers that occur on my inequalities. So I'm going to be drawing a vertical line at 0, so it'll intersect the x-axis at 0 as well as 4. So these will kind of be the sections where each graph is allowed to fall on. So my first vertical line will occur on the x-axis at 0, and then my second line I'm going to draw through 4 on the x-axis. And these will be vertical dashed lines just to show us where our graphs can fall and cannot fall. So my first vertical line is going to smack the x-axis at 0. Right there, bam. Alright, and then this one's going to smack the x-axis at 4. Right there, bam, smacks it right there. So my graph will occur on 3 different sections of the x and the y axis. So we have to figure out which equation occurs in each section. So let's take a look at our first equation, which is the lovely purple equation, which I'm going to call this 1. So we can figure out where section 1 will occur on the graph. So my purple function is allowed where x is less than 0. So x values that are less than 0 are going to be in this section because we have values like -1, -2, -3, and etc. So my first equation will occur in this first section of the graph. So it cannot cross the orange dashed line, but it will be everything to the left of the orange dashed line. Alright, so let's go ahead and graph the purple function, which I have the table below to help us graph. So we're going to be picking 3 x values that go in our chart. We're going to be solving for the y value because if you notice, this time we have x's in our problem, which make our problem a little bit more complicated than the last one. In our last example, these are only just numbers, so we knew it was going to be a constant graph, which means it'll be a horizontal line. But now that we have x values, they're going to turn into different kinds of functions, and we'll have to solve for the y value because our y value will not always be the same number. So, when we pick 3 x values in our table, you always start with the number at the inequality because that tells you where your start point is or your end point is, or possibly both, on your graph. Now you're probably like, holy hot dog, Miss Long, why are we going to pick 0? Because it cannot equal 0 because there's not a dashed line underneath it. Well, even though it can't equal it, this tells us where our start point is, and this will tell us if our bubble on our graph is going to be an open bubble, which means it cannot equal a value, or a closed bubble, which means it can equal it. So even though in this case we already know it cannot equal 0, this will tell us where the start point is. So we still are going to include it on our table. Now, we're going to pick 2 other numbers that fall in our interval. So I need 2 other numbers that are less than 0. So I don't know, I'm just going to pick -1 and -2. Why not? Sounds like good choices. Alright, so these are our x values. So in our points, I already know my x values. So in this part, we're going to solve for a y. In this point, we're going to state what the x and y value is in each point that we're going to plot. So I technically already know my x points if you want to go ahead and fill them in. We have x's at 0, -1, and -2. Sorry, -2. Now the y value is always still have to solve for, so I'll leave that part blank. Alrighty, so we're going to start by substituting in 0 in for this x right here. So we're going to have 0 squared minus 3. which that equals 0 times 0 will give me 0, minus 3 will give me a negative 3. So my first y value will be at a negative 3. So the first point I'm going to plot is at 0, negative 3. I'm going to do the same thing with these two x's. So I'm going to substitute in negative 1 for this x. So negative 1 squared minus 3. So negative 1 squared is negative 1 times negative 1, which is a 1. And 1 minus 3 will give me a negative 2. So my next y value is at negative 2. Alrighty, and my last x value. I'm going to substitute that bad boy in for x right there. So negative 2 squared minus 3. Negative 2 squared is negative 2 times negative 2, which is a 4. And 4 minus 3 will give me a 1. So my final y value will be a 1. So now we're going to be plotting these x and y values on our graph right here. Now, the only one that we have to question ourselves on are the numbers that fall on our inequality. Any other point that we pick in our table is always going to be a closed bubble. So these two values of x, I just chose the value in the interval. So these are going to be closed. Now, the first one we have to decide, is it an open bubble or is it a closed bubble? Now, since this one is less than 0, it does not equal 0, it means it cannot equal 0. So, this is going to be an open bubble on my graph. And the ones that you have to decide on will fall on your vertical dashed lines. So, my first one will be an open bubble, and my last two are going to be closed bubbles, because they do fall on my interval. So my first point is at 0, negative 3, and it will be open bubble, so I will not fill it in. My next one is at negative 1, negative 2, and it'll be closed. And then my final one is going to be at negative 2, 1, so negative 2, 1. Alright, now be careful when we graph these. These are not going to be horizontal lines, and you kind of have to know what the shape of the graph looks like. So in Math 2, you guys talk about quadratics, which involves an x squared. So if you ever see an x squared, that is a quadratic. And quadratics make U shapes, which are called parabolas. So I know this one's going to be a U shape, and if you're kind of looking at the graph, it's kind of making half of the U. So it's going to make one side of my U. So when I connect these, it's not going to be a straight line, it will make a slight curve. Alright, and I am going to put an arrow on the end because it does not have a stopping point. It starts at 0, but then it goes on in the negative x direction for forever. So I'm going to put an arrow. It does not have an endpoint. Yay, we got our first purple function graph. So now we're going to move on to the green function, which will be the same thing that we just did. Alright, now this one's a little different. It has a start point and an end point. And we always put these numbers on our table. Even if it can't equal it on the graph, it's still going to tell us where it starts and ends. So I'm going to put 0 as my first point and 4 as my last point, because that's my start and my end point. So 0 and a 4. Bam, just like that. Alright, and now I have to pick a number in between 0 and 4, which any number would work. But I'm looking at my equation, I see this 1/2 here, which fractions are our friends. We learn to love fractions. Alright, so I'm going to pick a number that will work well with this 1/2. So when we multiply something by 1/2, that's like dividing it by 2 or halving the number. So I'm going to pick a number that's easily divisible by 2 to make my life easy. So a number between 0 and 4 that's divisible by 2, I think that 2 will work out just fine. Alright, so just like before, we're going to substitute in these x values right here to solve for y and then get our points. Which, if you want to, you can go ahead and fill in your x values since you already know what they're going to be. 0, 2, and 4. We just got to solve for our unknown y value. Just don't worry, we'll figure out what they are in just a moment, so I know you're super excited. Alrighty, so I'm going to substitute in these bad boys in for x. So I have 1/2 times my 0 minus 3. Now half of 0, or 0 divided by 2, is just 0. And 0 minus 3 will give me a negative 3. So my first y value is at negative 3. Okay, I'm going to do the same thing with the 2. So I'm going to substitute in 2 right here. So 1/2 times 2 minus 3. So half of 2, or 2 divided by 2, will give me a 1. And 1 minus a 3 gives me a negative 2. So my next point is at negative 2 for the y. And finally 4. So we have 1/2 times 4 minus 3. Alrighty, so half of 4 is 2, or 4 divided by 2, still 2. And 2 minus a 3 gives me a negative 1. So my final y value is at negative 1. Alright, now, before we start graphing, we always question ourselves on our values in our inequality. So since I have 2 of them, we have to ask ourselves 2 times, is it an open bubble or a closed bubble? So on 0, since it can equal 0, that means it's going to be a closed bubble because it's allowed to equal it. So this one will be closed. Now the 4, since it cannot equal a 4, since there's not an underline underneath the inequality, okay, this one cannot equal a 4. So this one's going to be an open bubble. Alright, now any number that's not in our inequality or in our interval right here, we're just going to always say it's closed because it can always equal a number within the interval. Alright, and when we graph this, since my exponent, remember, if you don't see an exponent, there's secretly a 1 there. Okay, so this one, any function that's to the first power is called linear, which is kind of in the name. The way it looks like is a line. So it's going to be some sort of line. It could go this way or this way. So this time when we connect our points, it will be a straight line. So I'm going to plot these bad boys right here. So I got a point at 0, negative 3. Alright, now when I plot this, you're probably like, holy hot dog, Miss Long, we already have a point on 0, negative 3. We had it in our previous point. Well, if you ever have a point and one of them's open and one of them's closed, the closed bubble always wins. So we're going to shade in our bubble. Closed bubble always wins. Okay, so even though in the last one it couldn't equal it, this one it can. So we're going to close it. Alright, and I have a closed bubble at 2, negative 2. And I have an open bubble at 4, negative 1. So this function is going to start on this dashed line and end on this line. So since this one has a start point and an end point, it will not have an arrow like this one. We're just going to connect their dots. Just like so. And I apologize, this one should be open bubble. Silly Miss Long. Open. Hello. Alright. So I'm just going to connect my dots like so. Alright, so this is our second function, which occurs in this middle interval because it starts at 0 on the x and ends at 4 on the x. Alright, so we have one more function to graph. Get pumped up. I'm excited. Alright, so our final graph, so this one was our second interval. We have to figure out where our last function will lie. So this one are all the x values that are greater than or equal to 4. So if we look here, all the values that are larger than 4 or equal to 4 are in this section. So we have things like 4, 5, 6, 7, 8, etc. So this last section is where my final graph will occur. So it'll start at the orange line and go to the right of it. Alright, so same idea as before. We're going to pick 3 points from our inequality and we're going to solve for y and then graph that thing. So let's go. Alright, so I'm going to start at my start point on my inequality. This is my start point. Okay, so I'm going to choose 4. And I'm going to pick 2 other numbers in my inequality. Or in my interval. So some numbers that are larger than 4, I don't know, I'm just going to pick 5 and 6. Why not? Okay, so like before, we're going to substitute these bad boys in for x and solve for a y. Then afterwards, we are going to graph it. Alright, so on this one, I'm going to replace my x with a 4. So 4 minus 4, quantity squared minus 1. Alright, now before we start squaring things, we gotta do our parenthesis first, then exponents, if you're thinking about orders of operations. So 4 minus 4 will give me a 0. Alright, 0 squared is 0 times 0, which is 0. And 0 minus 1 will give me a negative 1. So my first y value will be negative 1. I'm just going to go ahead and write it in because I'm out of space. So my x value is a 4. And 0 minus 1 is going to give me a negative 1. Alright, same thing with the 5. So we're going to have 5 minus 4. Quantity squared minus 1. Alright, 5 minus 4, parenthesis first, gives me a 1. And 1 squared is 1. And 1 minus 1 will give me a 0. Had some space, yes. Alright, so my next point is going to be at 5, 0. Alright, and my last point, I'm going to replace this x with the 6. So we have 6 minus 4, quantity squared minus 1. 6 minus the 4 gives me a 2. Alright, 2 squared is 4. Minus 1 is going to be 3. Sorry, I ran out of space. Alright, so my next point is going to be at 6, 3. Alright, now before we graph this thing, I have to figure out which one of these points I have to question myself on. So again, we only question yourself on the point that, or the x value that falls on your inequality, which is the 4, right here. So, since x can equal it, because it has the underline right here, that means this one is going to be a closed bubble. So this is closed. Alright, and then any x value that's not on the inequality right here is always closed. So all of them are going to be closed. Yay. So these two will also be closed. Alright, and before we graph this, since we do have a squared, now I know it doesn't look like this one, but if you were going to sit here and multiply this out, you would end up with an x squared. So the squared right here is telling us it is a quadratic, which makes the lovely U shape, or our parabola. So when you graph this, it should make kind of a U shape. So let's see what happens. So I have a point at 4, negative 1. Holy hot dog, we have a point already here. Remember though, if we have a point that's open and a point that's closed, the closed one always wins the battle. They fought each other and this one wins. So it's going to be closed. It's going to fill that in. Alright, and then all of these are going to be closed. So I have a point at 5, 0. And a point at 6, 3. Okay. Alright, and we know it kind of makes a U shape, so when you're sketching it, kind of make it a U shape. There we go. And we're going to draw an arrow on the end because we do not have an end value. This one had a start and an end value. This one only has a start point, not an end point. So that means we're going to have an arrow that continues on to infinity and beyond. So this is what our lovely graph looks like, which, like before, I like to name my functions because they're awesome and they deserve a name. So this one's going to be named, we'll name it Penelope the Piecewise. So Penelope. Now, we're almost done with the problem. We have one more component, the domain and the range. Okay, so domain, that's always the x values on the graph. So when we look at the domain, we're going to be looking at the entire piecewise function, not just the individual sections. And I want to know all the x values that are allowed for the entire function. So the x values occur on this horizontal axis on the graph. These are your x values, or your domain. So when you look for the domain, you ask yourself, how far left does it go? How far right does it go? Okay, so even though it doesn't look like it, these two ends are actually going to get wider and wider. It doesn't look like it, but they are going to keep kind of extending off to the side. Sorry, not trying to make my graph ugly, but eventually they will extend out and get wider and wider. So if you ask yourself, how far left is it going to go? It's going to keep going in the negative x direction for forever. Okay, and if you ask yourself, how far right is the graph going to go? Since it keeps getting wider and wider on the x, it's going to extend in the positive x direction for forever. So to infinity and beyond with Buzz Lightyear. Now, there are two ways to write your domain. Okay, you can write it using inequality notation or interval notation, which we've kind of discussed those before. You can pick either option, but whatever you pick for the domain, you have to use the same notation for the range. So we'll start with interval notation. So one way you can write it, you always write the smallest x value on the left-hand side and the largest x value on the right-hand side. So this is kind of like how far left does it go? How far right does it go? So we saw on the left-hand side it extended in the negative x direction for forever, where the demon cats go. So since we're going for forever, that's going to be into infinity. We're headed to infinity in the negative direction. So we're going to write negative infinity for the left-hand side. The right-hand side, it extends in the positive x direction for forever. So we're going to write positive infinity. Now, the way that you write inequality notation, this includes all the x's on the left-hand side and the right-hand side are allowed. So we say that all the x values are allowed. And the way that we write that notation, it's called x is all real. All the real numbers are allowed. All the negative and all the positive. So in math, we like to use funky symbols, which I'm going to show you how to write x is all real. So you start with x. Now practice this with me. The way you write is or such that in math, we like to use symbols in math because mathematicians are lazy and they don't like to write things out if they don't have to. So you kind of make this little C thing and you put a line through it. That means x is or x such that, and the way you write all real numbers, you draw two vertical lines and you just complete the R. R stands for all real. So this is how you write x is all real. So you can use either of the notations right here. You don't have to use both. You just pick one or the other. So either of these are acceptable. Alright, so that's our domain. So you can pick either of these for the domain. Does not matter. So this is my domain. Alright, now the range. Those are the y values. So domain are x values. The range are the y values. So we're going to focus on the y-axis, which is the vertical axis. Alright, so we're going to be looking at the y values that are allowed. So we're kind of looking here on the y-axis to see what is allowed. Okay, so for interval notation, remember you have to pick one or the other. So if you use interval notation up here, you have to use it down here. If you like inequality notation, if you use it up here, you got to use it down here. So I know we're going to have some sort of parenthesis or bracket. So for range, you ask yourself, how low does the graph go? Or how high does the graph go? So the first spot will be how low does it go? The second spot will be how high does the graph go? Okay, which I'm not going to put the parentheses yet because it could be a bracket. Remember, we use a bracket if it can equal the value and a parenthesis if it cannot. So the reason why we use a parenthesis up here, remember you can't really equal infinity, so that's why I use parenthesis. So let's ask yourself, how low does the piecewise function go? So if I'm looking at my x, it goes all the way down to here. It doesn't keep going down to negative infinity, so be careful. So the lowest or the smallest y value is at -3. So I know it's going to be -3. Now you have to ask yourself, can it equal it? Well, since this is a closed bubble, remember the closed bubble wins over the open bubble, that means it can equal this. If this would have only been an open bubble right here, it could not equal it, so it would be a parenthesis. But since it can equal it, because it's closed, we're going to use a bracket on -3. Then you ask yourself, how high does the graph go? Well, if you look here, when you see arrows, that means they're both headed upward for forever, so to infinity and beyond with Buzz Lightyear. So it heads in the positive y direction for forever. And remember, it cannot equal infinity. You can never equal infinity, so we put a parenthesis. So this will be my range in interval notation. Now the way that we write it using inequality notation, whenever you use inequality notation, you always start with the x or the y, which the range are the y values, so you're going to have a y. and then you write the values where it's allowed. So since in this interval it's everything that's -3 and higher than -3, let's think about that. Does that mean that it's everything that's larger than -3 or smaller than -3 if it's higher than it? So let's see, these are things like -2, -1, 0, 1, 2, 3. These numbers are larger than -3. Okay, so I know I'm going to have a greater than symbol, greater than -3. And since it can equal -3, since it's a closed bubble, we'd say greater than or equal to -3. So that is how you'd write the range for our lovely piecewise function. The lowest y is -3, and it's everything larger than that and equal to it. So this would be your range. So remember, you gotta pick one or the other. You either write these two for your domain and range or these two. You can't mix and match. They don't like each other. Can't intermix these. Alright guys, we just graphed our lovely piecewise function, Penelope, and found our domain and range. Awesome job, you guys.